Okay, so we are in the review phase of our first few weeks of class, right? So we're just going to review everything. If you feel like you are lost sometimes and you don't remember how to do stuff, you're exactly where you're supposed to be. It's like totally okay to not remember everything. That's the way everybody is. Everybody. Some of my top students, one of my top students, Elliot, came back, you know, Nathan's brother, came back a couple years ago, and he sat in the back row, and I was teaching the easiest part of, you know, well, not the easiest, but a fairly simple thing in algebra. And he had just spent, he was in his year of geometry. And he looked up and he thought, he was watching me for a second, he says, oh, I remember that. But, it's like, that's the way it is. Our brains do that. So just if you're a little bit lost, fine. But use this review and use these videos. They're just going to be quick to just get you back up to speed if you need it. Okay? If you don't need it, don't use it. But if you need it, use it. All right. Bailey is twice as old as Charlie. 14 years ago. That's where I stopped reading. And I set up my chart and I fill out my entire chart before I read more. If you keep reading, you will try to squeeze all this other stuff into that chart. You don't want it in the chart. So here's the chart. You have 2 columns and 2 rows because you have Bailey and you have Charlie. And you have their age now. And their, what goes here? 14 years ago. Their age 14 years ago.
Minus 14.
That's minus 14, right? 14 years ago from now. 14 years ago would be minus 14. I'm going to write minus 14 for my heading in that column. So let's look at their age now. Bailey is twice as old as Charlie. Who's younger? So we'll make Charlie X, right? In general, make the youngest person X. And then it says Bailey is twice as old. So what would Bailey be?
Y.
Okay, but yeah, you can do it that way. No, actually, that's a really good point. You can use systems of equations. The trouble of using y is then you have to have 2 equations, right? If you have 2 variables, you need 2 equations in order to solve it. So we want to keep it with one variable so that we only need 1 equation. So if Bailey is twice as old as Charlie and Charlie's x, Bailey is twice x or 2x, right? Does that make sense? See that? So 2x. Now, what was Bailey's age 14 years ago? 2x minus 14, right? Exactly. You keep it really simple. 2x minus 14. What was Charlie's age 14 years ago? X minus 14. So x minus 14. Now, have we finished the chart?
Yes.
Yes. So now we can read further. Okay, 14 years ago, that means I'm going to use the 14 years ago column. Does that make sense? 14 years ago, Bailey, what was Bailey 14 years ago? 2x minus 14, right? Okay, so I'm going to do this word for word. 2x minus 14 was equals, right? It's just like same as is, but was is past tense, still equals. Okay, 4 times. How do I write 4 times, right? Parenthesis always means times. 4 times as old as Charlie. What was Charlie 14 years ago?
X minus 14.
X minus 14. So I just write that in. And now I just solve it. 2x minus 14 is equal to my distributive property, 4x minus 56, thank you. And then I'm going to subtract my 2x, only because I'd rather not subtract 4x and deal with negatives personally. So now I have negative 14. This crosses out. Negative 14 is equal to 2x minus 56. I want to solve for my x's, so I want to get rid of anything else. So I'm going to add 56. Okay. Now, that looks confusing, but really that's the same thing as this. 56 minus 14, right? Isn't that the same thing?
Yeah.
So, 6 4 from 6 is 2, 1 from 5 is 4. So it's 42. So I have 2x equals 42. Divide by 2, divide by 2. X is equal to 21. Right? Did I do that right? So now I've got x equals 21. Am I done?
No.
What does it say? How old are they now? Which column gives me the now ages?
Now.
Right, age now. So Charlie now is x. So Charlie is 21.
Oh my gosh.
Charlie is 21 and Bailey,
It's 42.
how do you spell Bailey, is 42. And that's my answer. Does that make sense? Okay. We're gonna, let's see. I guess we'll whatever. All right. I'm gonna do the number word problem last in case I run out of time, which I probably will. Okay. Can I erase?
No, wait.
Not yet. Okay. I'm gonna start over here then.
Next, solving for x.
We are now going to look with solving for x with fractions. Okay. That's the next one. Here, I'll use a different color. Purple. Okay. Let's say I gave you something like this. 2, 6, x plus 4, 6 equals 1, 6.
That's easy.
Multiply by 6.
Multiply by 6.
I multiply everything by the denominator, and immediately I get rid of all my fractions. Watch this. If I did this, if I multiply the entire thing by 6, would you agree with me 6 is the same as 6 over 1? Right? So watch this. So I have 6 over 1 times 2, 6 x plus 6 over 1 times 4, 6 equals 6 over 1 times 1, 6. Look at this. You guys all know how to cross reduce, right? Those 6's cross out. And look, all I have left is my numerator, my 2x, plus the 6's cross out. I have my numerator, 4, equals, the 6's cross out, I have 1. Did you see how I did that?
Yeah.
Everybody?
Yeah.
So this is a real amazing trick. To get rid of fractions multiplied by the denominator.
But what if next denominator is different?
Okay, we're going to do one like that. But now I'm going to quickly solve this. Minus 4, minus 4. So I have 2x is equal to negative 3. Divide by 2, divide by 2. X is equal to negative 3 halves.
It's just equal to 1.
Or I could write it as negative 1 and 1 half. But in algebra, a lot of times the fraction is useful. So, can you see it now? Can I erase this other stuff?
Yeah, sure.
This other problem? Okay. How about something like this? Where's my what? I'm running out of time. But let's say there are two different. But the key is that I multiplied this times 6, I multiplied this times 6, and I multiplied this times 6. Sometimes with fractions, it's easier to write them out separately. You see how I did that? It's easier to do that because then you can see what crosses out. But let's say I had something like this. Just want to make sure I don't use the same one. Okay, so 2/7 x plus
12.
Plus 1/2 is equal to 10. All right. If I were going to do this, actually, let's make it equal to 1. Just make it easy on myself. So if I was going to do this, if I wanted to get rid of this fraction, I'd have to multiply it times 7, right? But that wouldn't get rid of this one. If I want to get rid of this one, I have to multiply it times 2, right? So since I'm going to multiply everything by 7 and then everything by 2, why not do it all at once? What is 7 times 2?
14.
So 14 is my my least common denominator, basically, if I were going to try to add something, right? So I'm going to multiply everything by 14, right? Because 7, if I were going to add them, 7 and 2, I'd have to get common denominators with a denominator of 14, right? So just multiply by the lowest common denominator. And you'll see what happens. Watch this. So I have 14 over 1 times 2 7ths x plus 14 over 1 times 1/2 equals 14 over 1, or just 14 times 1. Right? That's my alarm. So once I've written that out, it's really easy to just cross reduce. 7,
Well,
I
it's
guess,
2.
sorry. 7 goes into 7. Okay, got it, guys. Got it. Thank you. 7 goes into 7 once. 7 goes into 14 twice. 2 times 2 is 4, 4x over 1, or 4x. Do you see that?
Yes.
And then plus. 2 goes into 2 once. 2 goes into 14 7 times. 7 times 1 is 7 over 1, or just 7. Equals 14 times 1 is 14. Now I've got an easy problem. I just subtract 7, I have 4x is equal to 7. Divide by 4, x is equal to 7/4. Or, if you want to, 1 3/4. Do you see how I did that? Oh, God. So, questions?
How do you do it?
How do you do it? Thank you so much, Gabe, for that wonderful question. See me after class.
Oh.
Okay. Good, you get it? You guys get it, right? Okay. So I know for some of you that may be a little confusing. Just remember, all I did was basically it's the same thing as multiplying everything times 7 first, and then everything times 2. Why not do it all at once, right? Now,
Could you do it by 7 and do it by 2 and get the same answer? But it would
yes,
take longer?
yes,
Take away.
totally. It would take way longer,
Oh.
right?
But
But
you
you
still
could
get
do
the same
that.
answer.
You could do that. You'd get the same answer. Great question. Absolute values. I'm going to just jump to this one really quickly.
Got 2 minutes, Gary.
I have to do acts as well.
If you want to ask for
See if I could get 3 more minutes. I've got to get used to this. The daily bites things always takes too much time out of my class. I'm not used to
Well,
it.
you explained it today.
All right.
We're doing absolute value.
All right. Thank you. Absolutely. Can I erase this? Can I erase this? Yes. All right. Quick. Erase. Absolute value. I explained it yesterday or last week. Like x plus 4 is equal to 10. So basically, the absolute value of 10 is equal to 10, and the absolute value of negative 10 is equal to 10. You guys all agree with me?
Yes.
You guys all remember this. Absolute value means distance away from 0. So if it's negative, it just becomes positive. Because it doesn't matter which side you are, it's just how far are you away from 0. Right? So I write it as 2 equations. The first one, without the absolute value signs, exactly the way it says. X plus 4 equals 10. And then I put the word or, and then I say x plus 4 can also equal negative 10. And then I just solve it. Subtract 4, x is equal to 6. Subtract 4, x is equal to negative 14. Now, however, sometimes you'll get a problem like this. 2 times the absolute value of x plus 3 is equal to 10. Why not? Now, suddenly, I have something in the way here, and you want to isolate your absolute value before you do this trick.
Divide by 2.
So we're going to divide everything by 2, right? Divide by 2, divide by 2, right? These 2's cross out, that becomes a 5. So now we have the absolute value of x plus 3 is equal to 5.
Oh my gosh.
Right? Sorry. You see that? So suddenly now you're back to something like this. It's really easy. So you're just going to say either, this could be either positive 5 or negative 5 inside the absolute value sign. So x plus 3 is equal to 5, or x plus 3 is equal to negative 5.
So it's 2 or negative 2.
Wait a minute, did I just do that wrong? Sorry. Oh yeah, right. Negative 5, and then subtract 3, x is equal to 2. Subtract 3, x is equal to negative 8. Right? Yes. And again, please circle your answers, even though I forget to sometimes. Up here. Ratios and proportions. It's just a fraction equaling a fraction. Remember, cross multiply? You guys all remember this, right?
Oh, yeah.
Right? So that's, I don't even have to cover that one. But I'll just show you really fast.
Are these all gonna be on
2x plus 3 over 4 is equal to x minus 1 over 3. So it would be this times this equals this times this. And then you just solve for x. So that would be ratios and proportions. So we covered that, we covered that, we covered that, we covered that. And I think that's all we're going to do. So
What about number of word problem?
we're not going to do that one.
Oh, you don't.
Did I say anything about word problem?
You did.
I don't see. What are you talking about, Gabe? Okay. All right.